Everyone. This time we'll be looking at calculations on Graham's law. We have two questions here that we're going to be looking at. And if you're writing any chemistry related exams, any exam um, like JAM, GCE, WAEC, I will encourage you to pay attention or other related exams and pay attention and learn how to make this work easier for you. So let's start with the first question. The question here is want to know 50 cm, 200 cm cube of hydrogen diffused through a porous pot. So what we have here, remember in Graham's law, um, rate of diffusion is always and then here we have when is time, when it has to do with time, it can also be equal to time. So what we have here, based on the equation we have it to be, we're dealing with the time. But now we say that 200 cm cube of hydrogen diffused through a porous pot, 30 seconds. How long will it take 400 cm cube of oxygen to diffuse the same pot? Now, what the first thing you do if you want to solve this question is to get the same volume, to know how the time it will take the same volume of hydrogen to diffuse in um, the same porous pot. Because this is 400, this one is 200. You get the value, the time it will take for 400 cm cube of hydrogen to diffuse in the same pot before you will be able to solve this problem. So the first thing we're going to do here is you can see that 20 200 cm cube of hydrogen is for 30 seconds. So 400 cm cube of what hydrogen will then be 400 over 1. That will give us 2 times 60 seconds. Give us 60 seconds. So we have 60 seconds. Now we will be able to apply this formula. Since we have the time, we don't have the rates. We're not talking about rates here, even though you can convert it to get the rate. But now we're working with this directly. This is what we are going to use directly to solve this problem. So we have it to be 60 seconds. That means for the hydrogen, we can call the hydrogen, time for hydrogen will be what, 60 seconds. The relative molecular mass of hydrogen M1 will then be 2, and that of oxygen is what, 32. Then we don't know the time it will take. We can call this one 2. So now let's go ahead and do justice to the question. Having the necessary information, having the information we need, the next thing we do here is to substitute. We have the timing, the time for hydrogen, and then oxygen, which we don't know. And again, we have relative molecular mass of hydrogen over what? Relative molecular mass of oxygen. So the next thing we do here is to open this square. We actually, to open the square, we have this to be 6 squared over this square will give us 2 over 32. Will give us 1. Here will give us 16. So we have over equal to 1 over 16. So 1 over 16 will cross over, cross multiplying. What we have here will be, it will then give us T squared equal to 16 times 60 times 60. 16 times 60 times 60. That will give us equal to 600 second. No, we're not there already. So we're going to open this square, get the square root. We get the square root of that. That's when we arrive at the main thing. You know that this one is squared. This is squared. Then the square root of 57,600 is 2,460 seconds. That is the time it will take. Thank you so much. And the next one we're going to do here is we're going over to the next question. The next question said we're going to calculate, say that under the same condition, hydrogen diffuse 2 times faster than a gas X. It calculate the relative molecular mass of this gas. So, which means if hydrogen diffuse 2 times faster, what it simply means is that for the hydrogen, it means that 2 times faster means 2 times faster hydrogen. Okay, sorry. Let's take it this way first. Rate of diffusion R 1 over root 2 equal to so this is what we're going to use. So in this case, what we have here is for the hydrogen, for the gas X, perhaps you can use X here and hydrogen here H. So for the air, X is 1, for the hydrogen is 2, equal to relative molecular mass of hydrogen is 2 all over relative molecular mass of the X that we don't know. So when we open this bracket, if we open this bracket now, the square root, if we remove the square root, we have 1 squared over 2 squared. That will give us 2 over mx. Then cross multiply. If you cross multiply it, we will have mx is equal to 2 times 2 is 4 times 2. That will give us 8. That means the relative molecular mass of the gas in question is 8. Thank you so much for being part of the class, and we encourage you to subscribe if you have not. And if you really want to support us, you can just do that by subscribing. And if you have any question, you can also leave it as in the comment section there, so that we can always attend to you. Thank you so much.